Okay, in this video I'm going to continue the problem we just started, and I'll do part C. And this one says we're going to take this /23 network and divide it into 8 subnets of equal size, and I want to write down the subnet IDs for these 8 subnets now. And so what I'm going to do is I'm going to go ahead and look back up at my diagram of the IP address, 32 bits wide, 23 bits for the network, 9 for hosts. But now I'm going to divide it up into 8 subnets. So I'm going to steal some bits of these 9 for subnetting and leave the others for hosts. And so what I'm going to do is so now subnet, let's see, I'm supposed to be writing here. Now we're going to subnet 10.10.10.0/23 into 8 subnets. Okay. And 8 subnet means we need 3 bits. 8 is 2 to the third, so we need 3 bits for our subnet ID. In other words, S is equal to 3. Okay, and so now we have our IP address. N is equal to 23 still. S is equal to 3. And let's see, what's left is H is equal to 6. And this all makes sense because now we have the number of IP addresses per subnet is 2 to the H, which is 2 to the 6th, which is 64. And this makes sense because our original network had 512 addresses in it. And so this makes sense. 512 divided by 8 is 64. Okay, so we really have divided it up into 8 pieces here. And that's all consistent with our powers of 2 here. Okay, so how do we do this? What we're going to do is we're going to have our IP address 10.10.10. I need to leave some room there for that one. .0. And again, the 10 is a 4 zeros and a 1010. And then this is 8 zeros for the 0. And now we have 23 bits for the network. We have 3 bits for the subnet, and we have 6 bits left over for the hosts. And so the subnets are going to range from 000 up through 111. The hosts are going to range from 0000 up through 6 zeros. Okay? And so we got to figure out what these values are. Well, we can do that in binary form if we want. What we're going to do then is we can look at 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, and there's going to be 8 of them. 1, 0, 1, 0, 1, 1, 1, 0, 1, 0, let's see, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, and 1, 0, 1, 1, 1, 1. Okay, so these are all 8 of them here. And what you're going to find is that you're going to go from a 10. You can see that it switches over. You're going to have a 10 in the third byte here. Your third byte is going to be 10. And then your third byte is going to switch over to 11 for the last 4. So for the first 4, it's going to be a 10. For the last 4, it's going to be an 11. And then here, the network IDs, the subnet IDs, have all zeros in the host addresses, yet these bits here. And these bits are just counting by 64s because this is the 64 and the 128 bit spot. So we can do it with all the detail in the binary, or we can just say to ourselves, look, we got 64 per subnet. And so I know that we're going to be counting by 64, 0, 64, 128, 192. And if I count by 64s, you realize it goes above 256 by the time I get 8 of these subnets. Well, that means I have to start over again. And so these are going to be the last octet. And then I'm going to switch over from a 10 to an 11. Okay, so here's how I'm going to kind of figure this out. And so finally, I'm just going to write these things down like this. I'm going to say that I've got a 10, am I in the right spot here? Yeah, I've got a 10.10.10.0, 10.10.10, 64, 10, 128, 10.10.10, 192. Did I write 196 before? No. And then 10.10.11, 0, 10.10.11, 64, 10.10.11, 128, 10.10.11.192. And again, these come from looking at setting all the host addresses to 0 and looking at these 8 bits for the third octet and these 8 bits for the fourth octet, where the last 6 are all zeroed out because we're writing down the subnet ID. And when these first 2 bits step through like this, we get this pattern: 0, 64, 128, 192. Okay? And now what's the slash value on here? Well, the slash value includes not only the network bits but also the S bits. So this is going to be a /26 network on all of these. Okay, so those are the 8 network IDs, and it's very easy to write down also the first and last and broadcast addresses for these. Okay, but this is all the problem asked for, so I'm going to leave it there, and I hope that helps and is clear.